Hello everyone. I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology, teaching you all microcontroller lab programs for 5th semester electrical students under 2017 scheme and 18 schemes 18 EEL 57 subject code. Today, I am here to teach you a program for arithmetic operations. Under that, I'm going to teach you the program to add the two numbers which are present in the external memory location, and the result is also stored in an external memory location. The speciality of this program is this program can be used for 8 bits, it can be used for 16 bits, it can be used for 32 bit, it can be used for 64 bit, and it can be used for the higher bits also, because a general program is written, and depending upon your uh, you can customize the program depending on the number of bits you are going to use it. So let us start with the program. So for starting up the program, we use Keel Microvision software. In the Keel Microvision software, as all of you can see, there are few tabs that are there in the menu. The fourth tab is the project tab. So you have to select the fourth tab, that is the project tab. After selecting the project tab, you have to select the first one, that is new microvision project. So let us select new microvision project. I am doing the program on addition, so I give the name as add. So add indicates that I am doing addition program, so I write the file name as add and click on save. It asks me which microchip you are using to do the 8051 assembly programming. So I select AT89C51ED2. So I use AT89. I type over there AT89C51ED2. So as soon as I select that, I will choose that and click on OK. Since I am checking the output in the same Keel Microvision software, and I'm not interfacing it, or I'm not using any other software for checking the output, I need not copy the image of the program. So I click no. So no indicates that I'm not using the image. So I write no. So as soon as I write no, I get in the project window something called target created. So this is how you create the target. Now I have to type the program. Where do I type the program? The program is typed in the editor window. How do you enable the editor window? Go to the menu tab. In the menu, go to the first tab, that is file. In the file tab, choose new. The editor tab will be enabled. Here you type the program. Let me type the program. So this is the program which I have typed for addition multibyte. Multibyte indicates I can use the same program for 8 bits. I can use the same program for 16 bits. I can use the same program for 32 or 64 or any higher byte also. So after you type the program, the next step in the procedure is to save. How do you save it? Again, go to the menu bar. In the menu bar, select file. In the file, select save as. A dialog box appears. I have to save the file in terms of assembly program. So I give add with an extension file .asm. So .asm indicates that it is a assembly language program. So I click on the save button after typing the file name. So you can observe here that as soon as I give the file name and click on save, it stores it in the assembly language program. Now I need to execute the program. Before I execute the program, I am going to apply the crystal frequency. How do I enter the crystal frequency? In the project window, there is target 1. I right click on the target 1. I get options for target. I click on options for target. I get this window. Here, by default, the crystal frequency will be showing 33. Enter 11.0591 megahertz as the crystal frequency, which is used for 8051 programming. In the output tab, choose create hex file. You have to check the create hex file. It will be unchecked. You have to go to the output tab and press the check button. You have to check it. Then you have to click OK. Now you have to add this file to the project. How do you add this file to the project? You have to expand target 1. You have to right click on source group 1. You have to choose add existing file to the group, which adds the respected file to the project. So I will choose add.asm and click on add once. So this indicates that I have added the program. Now I have to do the compiling. To perform the compiling, there are 3 steps. I have to translate, I have to build, and then I have to rebuild. So where do you find it? In the menu bar, you can see a translate over here. So click on the translate button. It says whether there are any errors and warnings. Errors and warnings are shown in the output tab, build output tab. Next, you are going to build it. It is going to link the hexa file. It is going to create the hex file, and rebuild is going to link the hex file. So after this, go to the menu bar. In the menu bar, you are going to go to debug. Click on start stop debug, which is going to, there is a dialog box which appears that says you have to press OK. So it is going to take you to the output channel. I am writing a program here where I am using 3 memory locations. The 2 memory locations are 8000 and 9000, where 8000 will have one data, 9000 will have another data. The result of the data present in 8000 and 9000 will be stored in the memory location 6000. So in this program, let us type the program in such a way that I'm going to take a 16-bit information. So let us see what is the information that we need to take. So let me say I am taking an information such as I'm taking a 32-bit information. It need not be 12 DEBC1A as it is shown here. I can take a simple one, 01, 02, 03, 04. I am adding that with 04, 06, 07, 08 also. So I'm taking a 32-bit information and I'm adding it with one more 32-bit information. So let me check how to perform this. So I require 3 memory windows here. 2 windows for storing the first number and the second number. The third window is to check the output. So go to the view button, go to memory window, click on memory 1, go back to view window again, click on memory 2, go to next button. You have to take memory 1 now. Next, go to view button, memory 3. So there are totally 3 windows which you can see: memory 1, memory 2 and memory 3. In memory 1, I will give the address as external memory is specified by X colon 8000 H and I type enter. It goes to 8000 H memory location. Here I'm going to feed 32-bit data. So to give 32-bit data, I say I take the number or I take a 64-bit data now. So how do I give a 64-bit? First, let me say 01. It is an 8-bit data. I give the second number 02. So 01, 02 together is a 16-bit data. I write 03. 03, now it's a 32-bit data. I write 04 here, which is a 32-bit data. So 1, 2, 3, 4 is a 32-bit data. I am adding 1, 2, 3, 4 with the next memory location. The next memory location I'm going to consider is 9000. So once again, X colon 9000 H. I will enter it. Here I will write it as 05. Here I'll write it as 06. Here I will write it as 07. Here I will write it as 08. So 1, 2, 3, 4 is added with 5, 6, 7, 8. So it's a 64-bit data taken with 64-bit data. So you're adding 64 bytes. Now in memory 3, I will write it as X colon. I am checking this in, I'm taking this, checking the output in 6000 H memory location. The result is stored in 6000 H memory location. So now let us go to the program. So first step is press F11. Now, since I am considering a 64-bit data at a time, so if I have a 64-bit information, at a time it is going to take 8-bit information. So 64 divided by 8, whenever we are going to take a 64-bit data, at a time you're going to take 8 bits. So what it is going to do is, at a time 8 bits are going to be, 8 bits are going to be added. So we have 4 times we are going to do the addition. 2 to 8 bits are going to be added. Like that, 4 times you are going to perform the operation. Instead of writing for 4 times the same program, what I do, whatever I do for the first number, the same thing will happen for the second time, third time, and also for the fourth time. So I create a loop. So let us see how to perform a 64-bit addition operation of the two numbers present in 8000 H and 9000 H memory location, and the result is stored in 6000 H memory location. So what does this do? It stores the count value called 4. Now the first data which is present in 8000 will be stored, the first address, source address, will be stored in R2 and R3. So 1 will be stored in R2. The lower byte of address will be stored in R3. Similarly, R4 will store the higher byte of address and lower byte of address is stored in R5. R0 and R6 will store the resultant address. So R0 and R6 are storing the resultant address. Before I perform any operation, the carry flag has to be cleared, because whenever I'm performing addition, subtraction, or anything as such, we have to do the carry flag should not be, the carry flag will get affected. Hence the carry flag should always be made 0. So I do clear carry. Now the first data is there in 9000 H memory location. So I go to 9000 H memory location. The first data is 05. How do I fetch 05? 9000 information. If my DPTR has to point towards 9000, 90 should go to DPH, 00 should go to DPL. So 90 is stored in R4 and 00 is stored in R5. So when I press F11, the data pointer will be pointing towards 9000H memory location. The data present in 9000H is 05, which will be brought to microcontroller through accumulator. So the accumulator will store 5. Next, I know accumulator is the only register which is used to bring the data from the external memory. So the data present in the accumulator will be stored in the register R1. So I'll store it in register R1. Next, I increment DPTR. So when I say increment DPTR, it increments to 9001. Now I store 90 in register R4 and 01 in register R5. Next, I want the second number. Where is the second number stored? In register R2 and register R3. So where is the second number? The second number is stored in 8000. 80 is stored in register R2 and 00 is stored in register R3. So your data pointer will be pointing towards 8000 memory location. The data present in 8000 is 01, should be brought to accumulator. So when I say move x a comma at the rate of dptr, it is going to transfer the data 01 to the accumulator. Now your dptr content will get incremented. Next, add C. So the data present in the accumulator, the data present in register R1 and the carry flag are going to get added. So the data present in R5 is the data present in R1 is 5. The data present in accumulator is 01. 5 and 1 gets added. The answer is 6 with no carry. 6 is stored in the accumulator, but I want to store the 6 in register R0 and I have to store it in the register R0 and R6. Before that, I have incremented the data pointer. So the 8001 memory location should be stored again to R2 and R3. So you will store 80 and 01 in R2 and R3, and your data pointer now will be pointing towards 6000H memory location. The data present in the accumulator will be stored in 6000H memory location. So when you go to memory 3 window, you can observe here 6 will be stored. So the addition of 5 and 1 is 6. So you've completed one data. Now again the data pointer is going to get incremented. So what is that? It is going to become 6001. 60 is stored in R0. R6 will have 01. Now it will, one operation is over. Still it has to complete 3 more operations. So the register R7 gets decremented from 4 to 3. 3 is compared with 0. Since 3 is not equal to 0, now it is going to go back to the loop. Again it is going to add the data that is present in 9000, that is 6, is going to get added with 2. So 6 plus 2 is 8. So the resultant will be 8, as all of you know. Where will the resultant be stored? It will be stored in 6001H. So as all of you can observe here, 8 will be stored in register, in 6001H. Now I completed this. So 2 operations are completed. Still I am yet to finish the third and fourth operation. So what is the third and the fourth operation? 7 should be added with 3. 7 plus 3 is A. All of you know 7 plus 3 is A, 0A. So 07 plus 03 is 0A. So the answer will be 0A, which will be stored in 6003 memory location. So when you perform this operation, you have got in 6002 memory location, you have got 0A. Next, it's going to perform 8 is going to be added with 4. After 8, 9. After 9, A. After A, B. After B, C. So in 6003 memory location, 0C will be the answer. So again, it is going to perform 8 plus 4, that is C, is going to be performed. So you can observe, you will get C. So after this is completed, now it decrements the R7 value, gets decremented. It is going to check the content of R7 whether it is equal to 0. When it is equal to 0, it will come out of the loop. So this is how we are going to do the addition. Let me give you one example. Instead of 64, if I have a 16-bit number, what would you do? In my count, I am going to say 02. If I have a 8-bit number, what do? I will say R7 equals to 1. So in terms of 1, 2, 4, 16, like that, we are going to consider the count values. So for higher bytes, we just have to take the count value greater. So this is how you perform the addition operation of a multibyte. Thank you for watching this video. If you have any doubts, you can comment in the YouTube channel. Thank you all of you.